Okay, in this video, we're going to try to understand the slope of a line. Now, to find the slope of a line, so don't forget, what we talked about earlier was a line is always going to have a constant slope, right? Any line is going to have a constant slope. And if it has some sort of a point, it's going to have an x-coordinate and it's going to have a y-coordinate. All right, so we'll call this x2, y2. We'll call this x1, y1. And that to find the slope, we're going to need 2 points, and how the slope is defined, it's going to be defined as the rise over the run. The rise, how high the line goes, all over how far out the line goes. Now the rise, since it's an up or down motion, will be related to the y's, and the run, because it's related to a horizontal motion, is going to be related to the x's. So that's how we come up with a little notation called delta y delta x, which is the change in the y values over the change of the x values. And in the equations that we use, some of them will have y equals mx plus b as a standard equation. M is going to be the notation we use for the slope. So let's do an example. Let's find the slope of a line passing through these 2 points. Okay, so now I don't know which one is x2, y2, and which one is x1, y1. I don't really care, and you're going to see why. So let's say that this is x1, y1. Let's say this is x2, y2. So let's find the slope by saying, okay, the difference of the y's, 1 minus 0. And now over the difference of the x's, 3 minus a minus 2. That's going to be 1 all over 3 plus 2, that's 1/5. Now let's reverse let's say that this point is x2, y2. So we're just going to reverse those. And so we're going to take a negative 0 minus 1. It's going to be the change of the y's, so 0. And the difference of the x's is a negative 2 minus 3. Negative 1 all over negative 5, 1/5. I got the same thing. It doesn't matter what points you use. No matter what points you pick on the line, you're going to get the same slope. Let's do a few examples here. Find the slope of the line. Okay, so it's the change of the y's all over the change of the x's, so let's just count. This one goes, the change going from this point to this point, I will go up 1, 2, 3 in the y direction. And I'll go over a positive 2 in the x, so the slope is 3/2. Let's do it a little differently. Let's go from this point to this point. Okay, so I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went up 9. And I went over 1, 2, 3, 4, 5, 6. All right, that's 3/2. Same thing. Let's go down. Okay, so let's say we're going from this point here to this point here. So what we would do first is we would go downward 1, 2, 3, 4, 5, 6. So I'm going down 6. And then I'm going to go over in the negative x direction. So I'm going negative in the x. 1, 2, 3, 4. It's always the same. Okay, let's take a look and let's do it from the point perspective, just for practice. This point here is 1, 2, 3, 1, 2, 3. Looks like this point is 3, 3. The other point is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think those are the points. So let's do the difference of the y's. That would be 6 minus 3 over the difference of the x's, 5 minus 3. 6 minus 3, oh, look, it's the same thing. So, slope is a slope, same for any line. Here's a couple special cases. The slope of horizontal and vertical lines. Okay, so if I have a vertical line, I'm going to take the slope of this line. So it's going to be the difference of the y's, so the slope is equal to 5 minus 1, and the difference of the x's is 2 minus 2. Slope is equal to 4 over 0. Wait a second, I'm dividing by 0. You can't divide by 0. This is not a zero slope. This is called undefined slope because you cannot divide by 0. So this is a very important concept. A vertical line where the x values are the same will have an undefined slope. Here's a horizontal line. So let's find the slope of a horizontal line. So let's say this negative 3 minus a negative 3. The x would be 2 minus a negative 4. This would be a negative 3 plus 3 because a negative of a negative. 2 minus a negative 4 is 6. Now I have 0 as a numerator. You can have 0 as a numerator. 0 divided by anything is 0. So this slope is 0, and all horizontal lines will have a slope of 0. Okay, we've already talked about this. The slope of a line is unique. It is the same anywhere on the line. It's not true for other graphs. For example, no matter where I'm at on this, the slope from this point to this point is always going to be the same. It's the same slope from this point to this point. It's unique. Let's look at a parabola. We can see that we actually have a slope that's downward here. This would be where the slope is a negative, be a negative value, and over here I'm going back up. So here the slope is positive, and the slope is changing every place on that parabola. So a parabola does not have a constant slope. Okay, here's a couple things that are important for us to know. Perpendicular lines have slopes that are negative reciprocals. So for example, if I have a line that has a slope of 2/3, the slope of the perpendicular line would be the reciprocal of 2/3, and it would be the negative of whatever value that is. For example, 2/3 and a negative 3/2 are reciprocals. Those would be perpendicular lines. Okay? For a horizontal and vertical line, these get very tricky. So if we have a horizontal line, it has a slope of 0. Its perpendicular line would be a vertical line that would have a slope of undefined. So for the horizontal and vertical lines, their reciprocals have 0 and undefined slopes. So you got to be careful there. Just figure that out by thinking that the horizontal line has a 0 slope, the vertical line has an undefined slope. Okay, in this next part is actually the way I'm going to do it this year. We're going to break this up a little bit, and this should be covered in a different video, so we're going to stop here. We've talked about slopes. That's as much as I wanted to do in this video.